welcome and thank you for coming, at least some of you. And yeah, my name is Viktor. I work here in this company for something like almost 10 years, and the last 5 of them is in the data science. And I would like to tell you something about the Jupyter notebooks or other implementation of the notebooks, because it's kind of quite common. Then when we are showing it to someone new, he's not kind of getting the concept and asking why we use them, what's on them, why not just write plain Python scripts. So what is Jupyter Notebook? In the short, it's the open source application for interactive computing. What that means is that you can just basically run the code in the web browser, put some descriptions, and produce output. You can put basically anything on output. You can run them locally or on the cloud. They are platform independent and support multiple programming languages. I think officially it's something like 40 or some number like that. But usually see them mostly with the Python, R, maybe Scala. Databricks use SQL even. And there is a kind of widespread adoption. And the Databricks SageMaker, you can create jobs in the SageMaker in AWS. And they are kind of core of Google Colab. So you can say that if there is something data related, the chances are that there will be some implementation of the notebooks. So what are the key features, why we like them? The most important thing is that they allow you to run the code, because we kind of pointless without it. You can write comments in the Markdown. It's really easy to work with the data visualization because you are in the browser, so you can work with the graphic as well. You are organizing codes into the cells. What it means is usually you write a kind of big piece of code. You are not structuring it very well, so if you can at least put it into the cells, which helps you with the readability, and it's easy to grasp and comprehend. They support number of extensions for, for the formatting or for the debugging and stuff like that could ease your life. And if you put a little bit of effort, you can get almost implicitly human-readable document that you can use as a basis for your discussions with the POs or on the coder or on the sprint reviews, and discuss your problems even with the non-technical people. So what is the architecture? The core of it all is Jupyter server. User is usually using web browser to interact with it, but you can also use another client like VS Code and stuff like that, but usually it's a browser. And when you send the code to execute, Jupyter server sends it using 0MQ to the kernel, which is basically where your programming engine resides. For the Python, it's IPython, which is a Python interactive shell. What version of the Python or packages are there is set by the environment you had. That's something that Marek also mentioned. It's a kind of good practice in Python to have isolated environment for each project. That means that if you break some dependency or something or you install something new, you usually are able to quickly delete it, reinstantiate it, and continue the work without breaking other stuff. So it kind of prevents something like DLL from old .NET days. And when the user wants to save the notebook, it saves to the notebook file, which is very long JSON in the IP, the NB extension. So I have short demo. And it's in the Google Colab. It's kind of similar to the Jupyter. It's fully compatible. On the top, you have basic control panel. But what is most important is here, where you see that kernel, and because we are on the cloud, you have the whole runtime. And by default, you have selection for the Python or R and CPU instance. What are the other nice things is that you can use also GPU instance for free for a few hours a day. which is really great if you want to start with machine learning and you don't have dedicated hardware. Because, for example, for some neural networks, it could run 10 or 20-fold faster on the GPUs. So it's kind of nice that you are getting it for free, because otherwise it would be kind of difficult. And the other stuff is the tensor processing unit, which is Google-specific hardware, and it's for the accepting TensorFlow. But you need to write code in pretty specific way to be able to use it. The GPUs can more or less trust. Like you can, it's if your algorithm can use it, it runs on it without much setting or something like that. So as I said, you can organize code to the cells. One is for text, where you can write in the markdown, or there is the code. Right now it's connecting to kernel, starting the environment, and booting up your Python. So I said there is a support for the markdown, so you could put basically anything there, different headings, text, different formatting, or use even tag for mathematical formulas. You can pass code, pass images. You can do basically anything there, which kind of helps if you want to document something that you are not bound to use only your basic commands in the code, which are hard to grasp. But of course, most important is that you can run the code. And as you can see, by default, if there is some output on the cell, it outputs directly under it. Here I am calling directly the print, but if your output is variable or function call, it outputs for you automatically. You are not limited to write only code there or execute the code there. You can also use command line commands. For example, here, the environment goal comes with some sample data, so I can list them. I can also install some new dependencies if I want to try something. And as I said, because you are in the web browser, you are able to output basically anything. So here I can also use some graphics. Here I'm using Matplotlib, which is one of the favorites, if then not most favorite, Python plotting library, where I just can print sinus wave. Here I'm just creating the array from 0 to 10 by 0.1 steps, put it to the sinus function, plot it, put some grid for variability, and put the title. So if I run it, you can see that I have a nice plot. But you are not bound only to that, because for some favorite or more popular data frameworks like Pandas, you can also print not just text, which is something that you would usually see in the command line, which is kind of hard on your eyes. This is some sample data from the Titanic survivors. It's kind of popular machine learning playing data set, but by default, you see this nice table. You could see it before on the Mark's presentation as well, when he was using the MLflow. And you can also create simple forms. For example, here, if I'm using IPy-widgets, I can input their text input, slider, drop-down, button, put their handler, bind it to the button, and just display it like that. And you got even simple form, which is kind of neat if you have some algorithm or visualization that's hard to set, so you can ease the others to work with that. You can also use some kind of meta commands. They are called magic in Jupyter. It's with these 2%, and it allows you to run interactive plots or output cells to the files and stuff like that, or use this simple which measures the time how long the cell is running. So here is set for the 5 seconds. So there is an output. And there is one last thing that kernel is able to do, and that I didn't tell you, and that's it retains the state between the cells execution. So here, if I assign the value to the x, I can run the other cells using that value. And this is something that really helps with the data processing. For example, if I would have on the beginning some data processing that would run for a few minutes or something, and I just need to tune some statistics or some hyperparameters of my machine learning model, I can do it in the single place without needing to run it again, which is something that I would probably need to do if I would be using just the Python scripts. Also, I can run the cells out of order. So for example, here, if I would like to have a longer wave, and I would like to, for example, change the color, I can do that as well. So, kind of quick demo. Doesn't continue. Yeah. So what are the popular notebook integration? The basic is that you can run it on a local instance. You can install it with the Python package manager or Anaconda. It grants you offline access, and you are not limited if using any of the extensions that could help you with the work. I selected the Databricks, which is basically your go-to platform if you are working with the big data or NI. And you can say it's primary interface for your data exploration task. And you can also use the notebooks as a place for your script, even for the running pipelines or delta live tables pipelines or any other workflows that are at your disposal. There is also a Spark integration, so you can write the code for the Spark and output the results in the Python or SQL, as I told you, and you can use both types of cells on a single notebook. What is a neat feature is that you are able then export the notebook as a Python script instead of that ugly JSON. So it really helps you if you need to merge the code with others under the source control. And the last one is the Google Colab that I showed you. It's a great way how to start with the machine learning or with the Python in general, because anybody can use it with a Google account, because just a Google app. As I showed, the main kind of nice feature is that you have free GPU runtime, and you can see or you can find many learning materials that are hosted on the Colab. I can show you some of my some nice examples. It's working with the over the time. The first one is, for example, Keras on TensorFlow documentation, which looks like your typical guides in the for any other programming language. Very good, some description code and stuff. But you can here click to the view in Colab, and you can run them even for yourself. It's using the GPU instance by default because, as I said, neural networks are kind of resource expensive. But what can you do as well is that you can change the values here, or you can, for example, do some profiling. I didn't run the previous, so yeah. So you can play with the code, which really helps with the understanding of the matter, and it's really easing you to getting better grasp of the concept. Other is from my favorite machine learning book. We have it in our library as well, which is this hands-on machine learning with scikit-learn and Keras TensorFlow, which comes with the public GitHub repo. It's a typical O'Reilly book with weird animal on the title page and these other weird icons for the comments. But you can, for each of the chapter, if there is something related to the code, there is a notebook. For example, here I got some chapter 7, I think. You can open it here, and you can browse it in the GitHub with the safe outputs. But again, you can run them in the collab, which is kind of neat because you can again play with the code, use the code snippets, and just play with it and get better understanding. Also, most of the illustration from the books or examples are outputs from this notebook. So it's kind of nice ecosystem. And this is one of the strong sides of the notebooks, that you can do the same. You can create some notebook and share it with others. And they, in the ideal case, they don't know, they don't need to download anything else or something. They are just take the notebook, run it, and see for themselves. But it's not just nice things. Here there are some drawbacks. One and the main is that it's hard to collaborate with under the source control, because I said the state files is a big JSON file which is really not meant to use by that's really not meant to be modified by people. So when you create some notebook and somebody other will make some changes, it's almost impossible to merge. Also, when you are using global variables, they never go out of scope until you restart the kernel. So you can, in the longer notebook, can start running a lot low on memory. They also encourages the monolithic, non-reusable code. You will rarely reference other notebooks. You can, of course, reference the Python libraries and stuff like that, but it's mostly some exploratory tool. So it's like not nobody counting here that you will be writing some nice code that you would like to use in the production, like one by one. There is also limited support for debugging. You, by default, you don't have breakpoints or stepping into the methods. Of course, you can download some extension that will allow you to do it, but we don't have very good experience with it. And also, its code is hard to test. It's not meant to be tested, so there is no support for the unit test. So what is our usual development pipeline, how we are using the notebooks? You can get the idea from the previous slide that they are great tools for the prototyping. What that means that if we are getting or we are starting a new project, you start with the firing up the notebook and use it for the data exploration. So you are loading the data and compute the statistic, plot some distributions. And when you get the better understanding, you can use the notebook for the prototyping solution. You can play with your algorithms. As I said, you can run only the part of the code you need, and it really helps you with the fast iteration. And when you are done and you are satisfied with your solution, you can use outputs and put them to the presentation on your sprint review or something to discuss with colleagues, which is kind of in the nice human readable form. And then you just take out the code, refactor it, and use it in your production Python script, or you will rewrite to the JavaScript or anything else, because it's really your playground, and you just trying to find a solution that works. And then when you have it, rewriting it to something else or to some of your production environment, that's the last and easier step. So I hope you get better kind of understanding why we like the notebooks and why we use them basically on our daily basis. And I hope you learn something new. So thank you for attention.